one of my closest friends is a top engineer at a big company and uses AI uses a little bit here and there. But he's like, look, my code is supposed to last for 20 years and it powers to some small degree a big part of the economy, right? And he's like, I'm not going to use AI because I think it's going to be brittle. And I think we're going to find in a year that all this code that we churned out in 2026 is going to have some kind of a flaw and it's going to crack. Do you believe that?
I respect it. I like it. I think it's good. I don't know if it's true.
Hello, and welcome to the most interesting thing in AI from Rethink, the Atlantic's creative marketing studio, in collaboration with PwC, a leader in helping organizations use AI. Back in November, Anthropic released Claude Code, and almost immediately, programmers could see that their jobs were going to change a lot. And one of those people who saw that was Paul Ford. He's a writer, a coder, an entrepreneur, and he's been building software for something like 30 years. During that time, he's also been writing about the ways that coding has changed, most memorably, including an article for Bloomberg Business Week called What is Code? I was quite jealous of it. I worked for a competitor when it came out, and I wished we'd assigned it. And he was also, I should add later, a contributing writer for Wired when I was the editor-in-chief there. So I wanted to make sense of this. I wanted to understand how AI is changing code. What parts of code is it good for? Is it good for Q&A? Is it good for writing it? What kind of coders is it really working for? The kinds of things that you can't understand when you're outside of the profession. So there's one person I wanted to call to make sense of it. Here's my conversation with Paul Ford. Paul Ford, welcome to the most interesting thing in AI.
Nick, thank you so much for having me.
I am very excited to talk to you. I want to start with just one big question. You're a writer.
Sometimes.
And you're an engineer.
Mm-hmm.
Which of those two professions has changed the most in the last year?
Engineer. Writer was already terrible, but writer is hard. Like writer has it. Professional writer still needs to go out, do the work, organize the stuff. Maybe they can use some AI tools. Engineering is changing fundamentally in every way.
What if I asked you to argue it the other way? Could you?
Sure, I could argue that, we're seeing plagiarism and we're seeing all kinds of scandals, but they tend to be, in general, as I talk to other writers, they reject this technology or they're using it to research and sort of, every now and then I'm hearing from people who are doing kind of automation to build like encyclopedic things and stuff like that. But for the most part, I think the business you're in, right? Like people are supposed to be, they can use AI maybe to do some research, but they have to verify it, organize it, and the words have to come out of their own brains.
All right. So the engineering profession has embraced it. The writing profession has mostly kept it at bay, certainly for the act of writing. The way people read is starting to change in weird ways.
I do think people are probably consuming more AI prose probably than any other kind of text at this point, right?
Which is a very strange phenomenon, because what does that do to our heads? And then what does it do to what we write? Which then what does that do to the models? Which then what does that do, et cetera, et cetera,
Oh, it's the endless, it's this sort of recursive loop where where AI models are reading the things that they themselves produce. And so I don't know if you've noticed this, but one of the tells for me of AI writing, and I think one of the reasons we find it kind of boring after a while, is that it's so symmetrical. Like you can almost see it from across the room. It loves to balance out the paragraphs. And real writers are kind of spiky brained.
It balances out the paragraphs and then it ends on these like dramatic sentences.
Oh, it's too much. It's literally everything that you would tell a 15-year-old, like, hey, this is great. Good job. But you got to kind of wind it down a little bit. And so it has that too much balance. Writing is not balanced. It's trying to bring balance to all the disorder.
So now let's talk about engineering. So Explain how you would write code, like what your setup was.
Sure.
5 years ago?
Sure.
1 year ago? And today?
Okay. 5 years ago, you would use a set of tools. They have initials, a text editor, or what's called an IDE, an integrated development environment. And I think, let's give me a project. What's something you would like me to build for you?
You are going to build a database of all of our advertisers, the outgoing pitches. You're going to update it based on their needs, and then you're going to give me PDFs of our pitches and then all data on our previous campaigns.
Okay, great. Now, first of all, 5 years ago, that's cool. The MVP, the minimum viable product, will probably be about $400,000. And we're going to need to work with you for a while to get all that data in. You need to give me somebody on your side of the fence to kind of get it all in. And we're going to, our backend people are going to work on the database and the server because we're going to create like a nice API and this whole system to kind of manage all that data. It's a lot of data. It's very mission critical. We have to be careful. On the front end, we're going to build a web interface, and it's going to use a set of technologies like JavaScript and React. And what's going to happen is you're going to be able to come in, log into this system, see all upcoming work. 5 or 6, maybe 10, 20 people are going to use it. We're going to roll it out with them, and we're going to test it. And then we're going to make sure it fits into the business, and then we're going to give it to you. And that's going to take 4 to 6 months. I'm going to put a designer on the front end, especially for the admin. It's nice to have nice admin tools. People work on this stuff all day. And we're going to have a front-end engineer, a back-end engineer, and a product manager is going to coordinate with your organization and with this team.
And how much am I going to pay you?
At least 400.
Okay.
I mean, some people will do it much less. Some people might say, why are you building? If you've come to me and said, I need this custom because I'm tired of the other automated tools, right? So I'm like, you want this really all for you, special for your processes, it's going to cost at least that much. And
right.
You're going
to worth every penny.
I mean, that's the whole thing. You need that revenue. You need to be able to justify that in terms of the business, right? So software is very, very expensive, and it often had to fit into a very challenging revenue environment. So most software kind of never got built in the past because it was pricey, or you pick something off the shelf and you said, I'll make it work.
All right. So that's 5 years ago. I'm paying you $400,000. You've got these, back end, meaning it's not facing the people, front end, meaning it is facing the people. You've got a product manager, meaning they're managing the engineers, they're talking to us, and you've got the engineers and they're sitting there going tick, 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 tick.
Yes. They do other things, but that's good.
That's mostly what they do. Okay. So now a year ago and now today.
So a year ago, we'll sort of put the two together, but a year ago, all that was getting weirdly faster in that you could use ChatGPT and you could use Claude, and they could help you write bits of code. The product manager part of it, like sort of the coordination part, hadn't gotten a lot quicker, but it could help you write specifications and guidance. So all the things that I think people think about with AI, like it writes documents, it helped me write some code. It helped me, I said, hey, organize the database this way, and it did it. And so I don't know what I'm charging you, but it's a real discount. It's like maybe 30% off because I'm going a little bit faster and you've learned about this. You're not going to let me get away with it. That's a year ago. And then November of last year, Anthropic came out with a version of Claude Code. So it's one of these tools. So instead of going into this development environment and having all these meetings, you just kind of tell Claude Code what you wanted. And it was, it kind of clunked wrong. November, it comes along, and instead of saying like, hey, I want you to build a web page, I want you to build a database schema, and you would sort of describe the components of this system, and it would build them. In November, you could say, hey, I want to build, and then kind of give it the paragraph you gave me, and it would build something that started to approximate that, and it would do it in like an hour. And then it was like, is this good? Is this quality? And what's happened over time is the products keep getting better, and it is good. Like, it's getting better.
All right. So now the equivalent product to what you would have charged $400,000 for 5 years ago, which wasn't perfect and was good, but we'd have to evolve it and there'd be bugs. The QA team wouldn't like it.
You'd have to keep paying us the whole time, right? Yeah.
So now, how much do I have to pay you to implement it with Claude Code? Say I don't have any engineers on my team. Paul, I'm hiring you, your company aboard. Come on in, do it. But I'm a good negotiator. What will you do it for?
It depends on how big you want to start and what you need. It would be like, I don't know, maybe $50,000 up front and $30,000 a month. More of a subscription type of thing, more of a relationship retainer kind of thing, because now you can have all the software you want. And so once you have one taste, you're probably going to want more.
So the cost is 1/8.
Yeah, here's what's weird. So I think, let me get to the real question you're asking. Building you the prototype. The thing and putting into your hand what might have taken several months before and been a huge chunk of that work might only take a week now. So that is fundamentally different. You're paying for a lot of experience and a lot of stuff like that, but like the actual giving you the thing you just described, I feel very confident that I could come back to you in a week and say, here it all is. Is this what you want? Now, normally that process would be very evolutionary. I'd show you bits along the way. You give me feedback. We do design phases. And so those moments of feedback are gone.
So now we're doing it in a week. It's 1/8 the cost. It's a very different process. A year from now, do I need you at all? Or do I just put in the paragraph?
I don't want to pitch myself. I think you should always put in the paragraph. It's not that expensive. You should go see what this is. And I always believe people should build if they can, because I think that's the way you learn. And it's the way I learn. So I would say absolutely go put in the paragraph. Like, and I don't mean this in like, go see where the gaps are and then you'll really need us. I mean, like, go learn. But what I'm finding over and over, I'm vibe coding a lot because I really wanted to understand this stuff. I shouldn't be because I'm the president of a company, but I am.
Vibe coding is you just type in what you want and the code appears and then you just keep rolling.
Exactly. I haven't, but you know what? I've been working on the same project for about 2 months now. And it's an unusual product. It's new. It has a new shape because of AI. And AI is not that great at building it out of the box, right? So I'm now 2 months into talking with the bot. I've spent hundreds and hundreds of dollars on tokens to get to this thing. It's starting to work the way I want. But that's just product work, right? So the code can happen really, really quickly. But the actual making a thing is still really, really hard. And I don't mean that in a like, hey, everybody's going to be okay. There's a lot of change that's been coming. But it's still really, really hard to make a good software.
I think vibe coding, when I'm vibe coding, it's great because I've never coded before and it's fun. And I'm taking a kayak on a river and I've never like been in a kayak or on a river. It's great, right? But for you used to code. And so in a way you're taking a new kind of boat. Like you used to have a different kind of boat. Like how does it feel emotionally to vibe code and to do the thing that you used to care so much about?
A lot of people react in different ways. I'll tell you exactly how I reacted. I had this experience of using it. I was actually on a plane. So it was the most ecologically damaging thing I could do was vibe code.
You're vibe coding on an airplane. And was it like an empty plane too? So maybe it even worse?
I literally came in and I went to my business partner who's much more suspicious than I am. He's like, hold on, organizations don't change quickly. And he's right about that. But I see the world just kind of like moving. And I'm like, oh, here it comes. And I was like, look, I literally said these words, death is coming, right? Like I was so taken aback because it was like watching a house get built in 5 minutes or, I mean, you've taken a Waymo, I'm guessing?
Yeah.
They're awesome. They're awesome. Yeah, I love Waymos. And so I'm in the Waymo and you're just like watching an entire structural part of the economy, which is people moving things from one place to another. And it's kind of going up into smoke as you're sitting in the back of that incredibly pleasant experience. And so I had that feeling. And I had it about all the...
But isn't it like taking a Waymo if you are an Uber driver? Like, isn't that what you're doing?
Yeah, I was really upset. And a lot of people were really upset. And how are you going to process that? And there are two ways to look at it. One is, okay, everybody's about to lose their job. And there's some evidence that lots of people are losing their jobs as organizations transition towards this technology. And then the other way to put it is that, hold on a minute, the code was never truly the hard part. The hard part was pushing things forward, coming up with new and novel ideas, communicating with consumers, building really good products that people wanted to use all day instead of getting frustrated, et cetera. Where this really does, I think, kind of sweep the leg a little bit is the enormous amount of invisible software that is all kind of the same. So stuff that just sort of talks to a database, the enterprise type of stuff that you just described, that is vulnerable because the architecture is really well known. And it's the same way that a LLM can write a pretty good college essay because it's seen so many of them. That is, in some ways, an enterprise application is like that.
What are the other elements of code where AI can be very specifically good, and what are the parts that are hard?
Sure. Okay. So the stack of technologies, right? So you have, let's say, a database or, a data source at the bottom, and then you have a way to access and write and read from that data set. And then you have ways to edit that online. And that's kind of an interface that comes through the web or it might come through another kind of application. So all those things together, and they have names like, you might use the Python programming language to access the Postgres database and so on. So that's your stack. And everybody kind of has a couple different stacks that they work in order to achieve different things. Classic kind of like, I'm going to let you put data in and out. I'm going to let you upload some photos. I'm going to make it possible for you to log in. Some people can see some resources in this system. Some can see others. That got real easy.
So the stack management. So information flows from level 1 to level 2, or from level 2 to user, or from level 2 to level 6 to user. That's all simple.
This is consensus programming. Right? This is kind of what you learn and do when you're a programmer for most organizations. You have a set of technologies and the documentation was on Stack Overflow and there was tons of code on GitHub that you would go and look at, and there were open source libraries you'd use. The LLMs absorbed all of that. And so they can regurgitate it just fine. And Claude in particular, but also OpenAI with Codex and now increasingly Gemini, like they're pretty good at iterating on the output.
Yep.
And so they make the code better through a lot of kind of old school processes as well as kind of LLM magic. And so you end up with these relatively good things. And when you read the code, everybody has to kind of admit, especially for stuff like that, you're like, it's not bad.
Mm-hmm. What is hard?
Product. And here's what I mean. I mean that like I can build stuff like that for you all day. And I'm seeing everybody do it. What happens is everybody, including me, you run off and you're like, oh my God, I can have anything I want in my head. It turns out that that's kind of not what you need. Like giving you the ability to create, I want to go for a drive. Let me build a new car, right? And but you can build the new car in 5 minutes. Right. Sounds cool. It's really exciting, especially to like a car kid. Yeah. But then you're kind of having to learn to drive over and over again. And so we're back to, and you sort of see this, the whole rollout of AI seems like we keep forgetting the user. We keep talking about how it's going to take all jobs or make so many jobs. But everything is so macroeconomic because it exploded so quickly and it all happened so fast and it was sort of so shocking. So what's tricky is that first week that I'm talking about, I have this experience over and over where we build something so quickly that it's very baffling to the person on the other side.
You've just made this really interesting point that's kind of stack management is easy. In journalism, writers don't use it to write for the most part. At The Atlantic, we never do. But there's a certain kind of writing that will be hard for a very long time. The kind of writing that requires reporting, right? Where you have to like go and make a phone call, right?
Or even, the archetype of the restaurant review.
Oh, right, because you have to go and eat at the darn restaurant.
I need to know what the food was like in the mouth.
Yeah.
Right? And so the LLM just can't do it.
All right, so restaurant reviews, reporting, writing with voice and style, they happen to be terrible at it, right? They just can't have distinctive voices. It all becomes homogenous and weird. What is the equivalent in engineering in code? Like, what is the equivalent of the restaurant review in code?
This is a very tricky one because homogeneity is a good thing in code.
Oh, right. It's a bad thing in writing, but a good thing in code?
It's a very good thing. Like the consistency, too much style means you're at a research lab. Like what you want is almost the minimal style. And coding is very, for a journalist, like very style guide driven. Like this is how our comments are going to look. This is how our formatting is very important. We're going to have tabs and brackets. There's all these automated tools to straighten stuff up. So where people come to me and they say like, it's not really working is sort of really complicated stuff like strange geometry problems and so on. I think when you hear about OpenAI solving some unsolved math problem, there is a lot of work going into that, like engineering the context for it and making it kind of get you to that output. You can't usually just kind of sit down and ask for, solve a great problem. You can't do that. So those things, they're using the ability of the tools to work really fast in parallel and do all kinds of really novel things. But the really hard stuff is still hard just because you have to express it very clearly. You have to create all the scaffolding. You have to kind of organize it.
It's almost like it's the opposite problem. In writing, you want to produce something that sounds completely different from anything somebody's done before. And you want to write a short story that doesn't feel like anybody's short story ever before, else it's not a good short story, sort of definitionally, right? And if a young writer came on and they sounded exactly like John McPhee, we wouldn't like it that much because we've already read John McPhee, right? But in engineering, you're trying to just kind of build stronger structures that will be longer lasting.
Absolutely 100% in every way. That's
right.
Like,
so a 10x engineer is not like a 10x writer. A 10x writer like looks at things and like puts it in a different way, finds a story that nobody found. A 10x engineer is like just a better construction worker.
Sort of. They can bring really advanced thinking and deep knowledge of the system into that structure. Ultimately, we want it to be, the word boring is praise in this world. And I actually used to get in trouble because I would go pitch clients and be like, we're going to build you such a great, like it's going to be such a boring system at its core. And they would panic. They'd be like, no, we wanted you to make something cool. We're like, no. So yeah, because computers want to break all the time. All they want to do is break. And so the 10x engineer is someone who can work within that environment, but bring incredibly deep knowledge and sort of innovation into it. So a good example would be, I remember I had a friend who was working on, he was writing his own database for financial transactions to handle huge streams of ticker symbols, right? Like just enormous amounts of transactions were flowing through. when he wrote that database, he took into account how the hard drive was rotating, when the head would touch the platter of the hard drive in order to maximize the amount of reads and writes that he could do. Most people cannot do that. Now, the LLM can help you. It can help you think that way, but you literally have to be able to know to ask it, where you have to be like, hey, have we considered this? And you, at that point, you have to be able to judge its output, because it is not guaranteed to get you the optimal solution for some really hard, really thorny problem.
So that's a form of like outside the box creative thinking, where it is like the writing thing, right? You don't want the output to look entirely different, but to recognize, oh wait, the rotation and the spin and the head. And I've noticed this when I have some like large journalistic problems that I use AI models on, and they'll run and I'll go and I'll check in the morning. And then I kind of sometimes have to talk to another human, reset the problem, reset them, and then we start making progress again.
Yes. So I've been similar to you. I mean, there's a whole field, which I think you could call like knowledge engineering, which has been lying fallow for maybe 20 years. And I'm starting to see it resurge. And I'll tell you what I mean, which is when you ask an LLM something, it'll kind of give you a good consensus answer. And you can ask it to go do more research and so on. But what's missing in the middle is like this kind of verification layer. So there's all sorts of things happening that are very interesting around like taking lots of information out of the media or out of documents, turning them into formal structures like databases, and then getting the LLM to interact with that. So there's these sort of verification loops that are getting set up. Anyway, I'm sorry, I'm nerding out, but this is kind of where my head's at.
Well, it is called the most interesting thing in AI. Like the whole point is to nerd out, Paul. That's why we booked you to nerd out.
You got the right guy, man. All right.
All right, talking about verification loops. What percentage of the code that you write at a board is read by an actual human before it goes to the client?
It depends. If it's a prototype, none, right? Like, hey, we did this for you. We just want you to see it, et cetera, et cetera. Like, take a look. If it is actual production software, all. Yeah, I mean, we're just not there yet. We're not there, especially if it's like, here's where I think it's going. Like right now, we're still in paranoid mode. We're professional, we're on the hook.
And you're paranoid about what?
Paranoid about not understanding. You have to understand what you're delivering. You really do. I had AI, I built a system to help me make PowerPoints to pitch. And I was fully transparent with somebody I was pitching. And I realized, and I'd read it all the way through, you tend to really skim this stuff. It comes out, and I realized halfway through, I wasn't quite sure what was on this slide. Like it had produced stuff. I'd read it, I'd seen it. I told the person I was using an AI artifact because I was kind of prototyping and experimenting. The pitch went just fine. But at a certain point, I had to admit like, wow, I don't know what this produced, because it's so easy to just like skim over.
Right.
You're not reading that output. Nobody is.
If you write a PowerPoint, the act of creating the PowerPoint and the act of making every slide means that you know what's on the darn slide.
And that was a good slap across the face, because I'm purposely as transparent as I can be about whenever I use this stuff. And it was like, hold on a minute. You thought you knew what was in here. You programmed it. You built the system, and you took its output and you showed it to someone, and then you didn't know what was in it for that exact reason.
Right. But you're not even, when you're talking about looking at all your production code, it's not just looking at the PowerPoint, it's actually looking at all those lines of inscrutable text that a normal civilian can't understand. Do you feel like when you read AI generated code, you can do a form of like human QA? Can you understand it enough to know whether it's good or bad?
Yeah, a good engineer can, absolutely. Absolutely. And it tends to be pretty good. Here's what's wild is it's gotten good enough. You're not going to find funny little bugs. It's gotten very good at fixing its own stuff.
Okay, so in writing, it does this very weird thing where it hallucinates, right?
Yes.
And you say, hey, find me 5 smart things that Paul Ford has said about engineering. It'll just make stuff up,
right? Good luck with that. Yeah, okay.
Well, there's certain kinds of queries where if there's not a huge, if you ask for like, give me 5 quotes from the Bible, it will give you 5 quotes from the Bible, right? But it won't say, I don't know. It'll just make them up, right? And then you'll be stuck, and I'll come to you in the interview and I'll say, you once said this. And you'll say, I didn't say that, right? And it still happens all the time, right? And that's a common error in the text-based world that I live in. What are the common errors in the engineering world that you live in?
So code has this amazing ability. It has to run. And so there's a verification step built into doing things with an LLM that produce software.
Yeah.
It makes the code, and then it runs the code, and then the code produces bugs. And it reads the bugs, and then it goes back and iterates on the code.
Yeah.
It's a loop. And so because of that loop, and because they're able, essentially like Anthropic and OpenAI and everybody else are improving the outcomes per loop, you end up with really relatively low defect code. This is pretty new. Like in November, there were lots of bugs, but it is getting better and better, just like almost on like a weekly basis.
One of my closest friends is a top engineer at a big company and uses AI a little bit, uses a little bit here and there, but he's like, look, my code is supposed to last for 20 years and it powers, to some small degree, a big part of the economy.
Yes.
Right? He's like, I'm not going to use AI because I think it's going to be brittle. And I think we're going to find in a year that all this code that we churned out in 2026 is going to have some kind of a flaw and it's going to crack. Do you believe that?
I respect it. I like it. I think it's good. I don't know if it's true.
Mm-hmm.
So like, we have beliefs that kind of guide us. And I think that's a good guiding belief because some of those cracks are going to be there. And he should keep an eye on the code that runs 20% of the economy. Like I've been able to do a kind of programming I always wanted to do, which is sort of chip level. It's called FPGA programming. And I've been using it to make synths that make cool sounds, beep,
Yeah.
boop. The same kind of programming is also used for high frequency trading. You make the chip sort of deal with the trades and sort of process the information coming in off the exchange. The exact same process. I can do a kind of coding that was way too hard for me before, and now I could do it. I could build high frequency trading systems. Yeah. I would never feel confident deploying this at my level of skill, even though I could do it. And I think that's something we're all going to be triangulating. I have no problem making something go beep and boop.
Right.
But I would never.
But you would have no confidence putting out your code for high frequency training, whether it was Paul Ford right on his computer disconnected from the internet or Paul Ford vibe coding, right? Both of those don't work.
That's right. And that's your danger, right? It's the sort of, what is it, Dunning-Kruger? Like you just kind of get that sense of, there's a sense of miracle happening. And what happens is everybody produces code and they're like, I did it. My beautiful baby is here. And it only took 2 hours instead of 9 months. Don't you love it? And you're like, actually, not really. And then they're still hurt. Engineers are now producing so much more code than they used to be. And the rest of the org, they're bottlenecking because there aren't enough product managers to help them decide about what to ship. There aren't enough designers to make the design unique. And so you have this very strange situation where what used to be a balanced professional environment, which was I got a certain number of product managers and they have a bunch of engineers that they usually work with and a couple of designers and another few specialists, and that's how we ship our platforms. The balance changed because the engineers could suddenly produce like 50 times more stuff. You've got your friend who is like, no, I am not going to mess with this because a chunk of the economy runs through my stuff. Okay, so you're probably leaving him alone for a while. He might start using some AI around the edges, but ultimately he and that code are very simpatico and he doesn't want to give it up. Now here's what's real. You're in between these two worlds. You got one guy saying it's all going to be brittle. It's all going to be terrible. You got to watch out because the bad times are coming. Some of that's going to happen. Some terrible bug is going to get introduced because nobody bothered to look. It's going to have catastrophic effects. It's just going to happen, right? Because we're humans and we're using tools and this always happens. On the other side, everybody's using this stuff. Some people are using it well, some aren't. I don't know. Do you believe that people who are mediocre can be upskilled? We have a beautiful robot that could upskill them.
I have yet to see a writer who was like mid-level talent who used AI and became a top-level talent, right?
Yes.
I haven't seen that, right? In the world that I know and that I can judge, it may well have happened. And certainly AI makes me much better at a lot of what I do, but I just haven't seen the kind of middle to top. Have you seen that in engineering?
Writing is such a different kind of thing, right? Because, okay, how would an AI truly upskill a writer? Writing is this mix of like long-term thinking, deep subject engagement, and then developing a kind of tonality and a way to express relatively abstract ideas.
If I were a writing coach and I were trying to explain how to use AI for writing, I would take a writer who has good style, good voice, good reporting skill, good judgment, and show them how to do research, use agents to use research and then start churning out many more stories. Try to find the writer who's blocked at the research level, not at the write nice sentences level.
That's velocity. That's not true upskilling for a writer, right? So it's this sense of quality, right? If velocity is like, hey, we're doing a lot of, you're a business reporter. It's a good tool for a business reporter. It can help you understand a whole industry. It can help you make sure you're covering competitors. It can help you go out to the web and see what everybody's launching in a given week. So that would be a radical upskilling of a pretty average business reporter to be like, hey, you keep forgetting to call competitors when you do these stories. You're kind of funneling press releases and I need you to do better. You probably could upskill them, but you're not going to get quality out of that. You're just going to get velocity. And that is what happens with code. It writes better JavaScript than I do. But if I sat down and really worked on something for, a day, I could write one really good piece of code. That was probably normal velocity for me, but it can do 50 or 100 of those in a day. And so I can't compete.
Let's go back to the product managers and the designers. So one theory, this is a theory that a lot of folks in Silicon Valley say, is like, well, all the product managers can be able to do engineering. They're going to be able to do a little bit of design. And it's all going to flatten. And
Sure.
like the lines between these people are going to blur.
Yes.
What you're saying is the lines aren't really blurring, or maybe they're blurring a little bit. What's changing is the output of each part.
Here's what I know. I know that product managers for many, many years have actually been exhausted by designers and engineers. Engineers think product managers are getting in the way of them doing important work that involves them doing things on their computer and not talking to product managers. Designers are just like, why don't people understand how important design is? And so everyone gets everybody else's skills all of a sudden. And it's just a festival of vengeance. It's just like, oh my God, look at me. I can build my own apps. And what I see is, here's what I see. I see product managers building things that actually, they're so excited to ship the software, but a lot of what they're doing is essentially just kind of nicer interfaces to databases that they could have done with Airtable. But they're so excited to own the process. Designers who are spinning up all kinds of designs and then able to build sort of platforms underneath them, they're like, wow, I have the power. And engineers who are like, I don't need any of you, I can ship all day. What we found over the last 40 years is that if you don't have a sort of collaborative discourse around what the product's going to be from these different cultures and from work cultures, and also sort of from users and so on, you won't really have a good product. You can get a lot of code, you can get a lot of software, but it might not be something that people engage with, or it might not really solve the problem you're describing. And so I feel that everybody, when they get these tools as sort of primates, we're just like, how do I get, the value here is immense. How do I get this value? How can I show how valuable my brain is? What can I do? And the reality is, I think we're actually all going to have to work together again in order to build good product.
All right, that's a lovely theory, Paul. I like a lot of it. But let's go back to the Festival of Vengeance.
Yes.
If you had to choose one team, you've got the product managers, you've got the designers, you've got the engineers. Who is going to win with these AI tools?
Depends on the application. If it was the original one we were talking about, like the contract management thing,
Contract manager, yep.
I think that the product manager might win that one because it's all known, understood stuff, and the robot will do a pretty good job for you. Maybe with an engineer coming in to evaluate, okay, for more granular data-driven stuff. Like if I was building an analytics platform and so forth, lots of room for the product manager and the designers to guide. But if it's like sort of a big, messy set of data problems, the engineers are going to win.
So where does the designer win?
The designer wins when everybody realizes again that everything that Claude produces looks about the same. But we're so shocked. It's sort of like remember when the images showed up, you can't see the glaze at first. And then like a week later, AI generated images, you're like, oh, that's AI generated.
Right.
It's a little bit like that with product. Claude keeps using the same type hierarchy. It keeps sort of designing everything the same.
This is so interesting, right? So like there's this amazing study of writing with Gemini, right? Where you take a bunch of papers that were written before ChatGPT came out. You then have AI edit them. You then show them people. Everybody's like, oh, it all got better. Well, it all got more interesting. Oh, it's more creative. And then you analyze them as a whole and they're all the same,
Yes.
right? And they've all converged towards kind of a weird mean. Is that what's going to happen with design? Every engineer who's using Claude to design their new product, all the products will look the same. So you actually need the designers to say, no, not that, this.
This is a very weird era, but humans, like, it's always been thus. Like, we always come up with a system or a framework or a component library or a toolkit, and we're like, good, you don't need anybody right now. Like, if you go back to the 90s, Steve Jobs is moving boxes around in Next computers, which became Apple's operating system. And it's all about sort of, all you're going to need are these objects. You can kind of move them around, and then you'll have all the code you need. And then, look, there's zillions more engineers and software people than there used to be. We've been trying to we're always trying to kill this cohort. And I don't know, somehow humans just mess it up and need more novelty and more design and more thinking every time. And so I have this ideology, which is just like more software, more people building tools for themselves and their communities is just inherently better. More people able to publish on the web, there are so many organizations I had to turn away, like really nice, do-gooder, transit-oriented, just whatever. And I would have to say, you just can't afford what you want. You have to use software off the shelf. I know you want to do this, and I know you want to send everybody a tote bag and understand your reader or your cohort better, but I can't help you. They can have their thing now. And so that means that more people could help more, lots of other people. So I just sort of feel that it's going to bubble up that way, as opposed to, and this is a feeling, this is a vibe, because right now what the Valley wants to do is just like, look at our AI efficiency. We got it. We're going. But I just, every time you hear one of these studies where, we got rid of our call centers, and then there's like 6 months later, there's a like actually 70% of call center projects have failed. And so we've had to start rehiring people because it's actually not able to just do it yet.
Your kids are 14?
Yes.
Are you telling them to learn to code?
I have twins, by the way, so because it's going to be confusing to everyone.
Yeah, you could have had 7 kids the way I phrased that question.
But they're all 14. Yeah. This is a very tricky one. So my son was sort of programming inclined. He read a book about Python. We talked about it. We started to vibe code a little bit together. He got kind of bored with it. I think understanding how systems work deeply so that you have an intuitive sense of what's going on in the world, whether that system is a computer or politics or the clothes you're wearing or how food gets made, is like kind of the best thing you can do as a human. So if you're inclined towards this stuff, I would be very paranoid about hiring somebody to vibe code all day who had only vibe coded all day and hadn't kind of looked in.
So you would suggest that they learn Python, even though in the future they'll just be vibe coding with Python, because the act of learning Python teaches you something about scripts, about errors, about systems, about structure. But isn't that like a little bit like learning Latin or something? Like,
so what? Learn Latin too. Like I learned old programming languages. I learned all sorts of arcane stuff. My midlife crisis is trying to learn piano, and I'm terrible. But I'm trying to learn music theory. What's it going to do for anybody? But it actually does give you a different way of seeing the world, and makes me, piano doesn't make me better at my job, but like understand.
It might make you better at your job. I mean,
it certainly helps me focus in the morning and et cetera, et cetera.
Well, no, but there's also a theory that like stretching your brain in any way and like activating neural pathways you haven't activated before sort of increases creativity. Like brush your teeth with your left hand, and then actually you'll be more productive during the day doing other stuff.
It's great. So every week I go and I'm richly humiliated by a very nice piano teacher, and then I think it is good for my brain. It teaches me humility. I learn about a system that I'm not I'm literally trying to understand Bach in my 50s, right? And that's great for me. It drives. I don't talk about it to anybody else, but it really is something to do on the train. And so I think trillions and trillions of dollars. The world has changed. Robots now talk like people. Like, if you're at all curious about the system, you should poke around. You should learn how it works.
I don't know if you remember this, but I was working at the New Yorker, and you had written some posts for the New Yorker. You had recommended a lot of engineers. And I had this idea. I was like, let's take a database of all the edits that have ever been made on New Yorker stories that were saved, right? So we have the final stories, we have the drafts, and we have the edits. And I was like, Paul, let's go through this and let's build an editing system. We'll build could have built Grammarly, but out of like the New Yorker corpus. And you wrote back and you're like, this looks really fun. We sort of got together, we talked about it, and then it just seemed too hard. And I think it was, right? It was too early, right? This is like 2015, right? But if we had had that idea in 2021, 2020, right, we could have built Grammarly, right, which is worth however zillions of dollars it's worth.
Yes.
Right? How do you time it right?
Oh my God. Go to the Valley, they'll tell you. I've ended up sort of in services because I like helping people. And that's kind of, everybody always has software problems. And my job is to stay informed and then help them with their problems, right? Timing is kind of almost like gambling, right? Like you're just you had a really good idea. And in retrospect, if you'd thrown a couple of machine learning experts at it, you probably could have built a really good tool and it would have had the New Yorker brand on it. And it could have worked back then too. It just was like, that was going to get into the hundreds of thousands of dollars really fast. And, you only have a certain amount of budget and bandwidth.
I think I had $5,000.
Exactly, right? So but that's it. Like you needed experts, you needed all kinds of stuff. You could do that now really quickly. You could do it at the prompt. And the funny thing, I think here's something that the code of it isn't going to be the hard part. You can say, hey, what models and verifiers and systems are going to work? We're going to feed it here. I'd like to integrate it with an LLM, and we're going to put it's got to use these New Yorker archives in a really specific way. We want to get these kind of pro style things happening. We want to measure the output and all that. Everything I just described to you, like again, prototype in a week. Okay. So the code's not the hard part. what's interesting about that problem is that the New Yorker has a data set that nobody else has. It has a history of edits. That didn't look valuable to anybody until you thought it was valuable, but then it was very expensive to bring that value out into the world. That value is actually very inexpensive to bring to the world right now. Like I would not hesitate to ship a product like that today. And so if you think about it, back then, the code was the expensive part, and that was going to be the product, and that was going to be the moat. And it would be cool. You'd have the New Yorker imprimatur, and you would have the code, and it would be kind of your system. The code will not be the expensive part in the future, but the expensive part is that database and that knowledge and that little moat of knowledge that the New Yorker has about how to edit that you could sell and communicate to people. And I think that is the real change that is coming, is you're going to end up selling that moat and that data and how you perceive and sort of integrate with the world, as opposed to saying, I have software no one else has.
Right. And so the interesting thing, and there are also like all these hiccups as I've thought about, could this project have worked? First, I should add, it wouldn't have made us both billionaires, but it would have made Condé Nast billions of dollars.
They need it. They need it. Okay, keep going.
And it would be great. More money for more journalists is fantastic.
It is. That's true.
But the data actually, they get super interesting, right? Because the drafts of stories maybe include material that was litigious, right? And it was taken out because it reveals the source in the Abu Ghraib story or whatever, right? And so you realize as you dig deeper and deeper into these data problems that sometimes they're weird hiccups.
Yes. And how now I need a product manager and I need people to serve. Like, you see, right? So think about the future product. It's not the code. It's that sort of, you're going to bring this system and this way of thinking out to the world, and you need an enormous amount of judgment to do it well. So how do you get rid of that? And I think the true AI accelerationist types will be like, just wait. You're going to tell the LLM, you're going to say, go ahead and make sure nothing in this is litigious.
Yeah.
And that might kind of work, but how long until you're really ready to go to that floor of lawyers at Condé and be like, no worries, guys. I got Claude's on it, and we're just going to, I already shipped it. Don't worry. It happened on Thursday.
Yeah.
And you watch the law leak out of their brains at that point.
What is the thing that's coming for engineering after agents?
Oh, I don't know. Like, flat out, don't know. I think what you're actually seeing is we're entering a phase of steady incremental improvement. The models are not getting radically better on a regular basis. Like, I don't think we're going to see that. Claude Mythos is very, very good at coding, but it's not like 100 times better at coding. It's just kind of incrementally better. And so what you're going to see is more and more classic software in the loop trying to help you along in the process, which means that certain tasks are going to get easier, like probably database stuff, things that people do all the time. So I think you're going to see a lot more ease. I think you're going to see a lot of people able to get into stuff and build stuff. You're going to be able to build so much more stuff in a year, right? So I'm actually less worried about the engineer. I think the engineer is probably the person with a lot of experience. I don't know if they're going to be a zillion times faster next year, but if you're interested, I think more people are going to get to come in and participate.
Do you think that there will be like crazy creative engineering problems that are solved? Like the creation of Bitcoin, right? Like brilliant idea. It took a bunch of other inventions, put them together, figured out hashing protocol, security protocol, proof of work protocol, took a bunch of ideas from other people and mixed them in this genius way.
Yes.
Do you think that AI will be able to do projects like that?
Yeah. I mean, I think that comes out of the cypherpunk community and mailing lists. And there was lots of prior art, and there were, all sorts of systems for like email verification that it all kind of fed into Bitcoin, right? So it came out of culture. It came out of a very specific culture that very, very few people were part of. And then it kind of exploded everywhere because they replaced money. And so think about that, right? So how are you going to do that? Let's solve it. Okay, you're going to sit down at Claude. You're going to say, hey, Claude, replace money. Right? That's actually that's kind of what we're talking about. That's not going to happen. You can implement readily. I don't think that, like, if it comes up with an idea of something a computer can do, you can implement. The thing about Bitcoin, though, is those ideas had been floating around. It was the one that locked in and everybody got excited. There's just no way to predict that. That was humans in aggregate.
Is there a piece of code or a bit of engineering that you consider sort of the canonical, most creative? Like, what is the, I don't know, James Joyce Ulysses of code?
Oh, that's a great question. There's a few. I mean, I'm fascinated by long-running open source projects. And so the true Ulysses is actually probably the Emacs text editor, because it's deeply recursive. It's a text editor, but it does everything. And at different points, it will browse the web. It will send email. It has a version of Tetris built in, but it's all written in the sort of the programming language Lisp. And it goes back really like 40, 50 years at this point. And you can read that whole history. And there's all sorts of people coming in and out. And actually, one of the things I like to do as a big nerd is make that history more explicit narrative using LLMs. So that's one. From a sort of creative point of view, there's a text-based game called NetHack where you kind of move your cursor around and go through dungeons. That's been around for 30 years. And it has had a core team sort of building it the whole time. That's all open source, and you can read the code. So those would be two good examples. My all-time favorite right now is there's an open source music synthesizer called Surge XT. It's one of the best run open source projects I've ever seen, and the code is fascinating because audio is hard. Like, it's just really lots of little tiny bit level things, and so it's just sort of a lot of the science I would like to understand is inside of that.
All right, last question that I ask every guest. If you had an unlimited research budget in AI and you could fund whatever project you want, what would you support?
An enormous number of relatively do-gooder organizations are very curious about this stuff because they've been very underserviced. They do things like case management. They have tons of tech problems, but they're strapped into legacy platforms, and they can't get off of them because it's very expensive, and they're spending often hundreds of thousands of dollars a year that could go to their constituents. I would love to build a lab that sort of builds those things, as many pieces as possible for them that they could then assemble with this stuff themselves. I think you could really help people who've been very, very underserviced by tech.
So this ties in to one of my favorite ideas from this podcast, which is when I interviewed Audrey Tong. And one of the things Audrey said is there's a vertical race, right? It's Anthropic versus OpenAI versus Grok, right? And it's going towards infinity and zillions of dollars. And then there's a horizontal race, which is everybody else, right? And it's the civic science organizations and it's the educational institutions. And they're like building values and verification. And if the horizontal race goes as fast as the vertical race, then it summons the Buddha into this giant AI, world we're moving into. But if it doesn't, then that's where you get dark outcomes. So I kind of love your theory as a way of like accelerating the horizontal race.
And I don't think it would be that expensive. Frankly, you say infinite, but it's just like right now, priorities. If you talk to people who are trying to do AI for good, they don't have meeting spaces. Like, there's just like the infrastructure is absolutely aligned with this enormous capital expansion. The way the tech industry tends to go is, I think, everybody will have their IPO and they can go relax, and then the rest of us get to kind of clean up the mess. But hopefully there'll be lots and lots of value there. And that's my hope.
And far less expensive, right? The example we gave at the beginning, right? The $400,000 system from 4 years ago, that's a $50,000 system now.
Yes.
Probably applies for a lot of these great nonprofits.
And the AI itself is going to get cheaper. So I think there's tremendous opportunity to make and do things that wasn't there before, along with all the other problems and bad stuff. And to me, I just believe the software kind of unlocks people. It's a tool, and it can unlock companies. It can unlock communication. And so anything that could do that is really valuable.
Well, I hope you write up a plan for this. You post it on the internet at F-Train, and then someone listens to this podcast and then funds it with $1 billion.
Let's do it. Let's get that $1 billion.
All right. Awesome. We could have done it if we just built Grammarly.
Yes, we should have done it. Well, we would have just made Conde a whole lot of money.
Anyway. All right, Paul Ford, thank you so much for being on the show.
It is my privilege. Thank you.
That was my conversation with Paul Ford. So I'm going to admit I've used AI to write a little bit of code. I've become more comfortable in Terminal and with Python. Probably the best thing I've written is a password cracking system, trying to get into an old PGP password that I forgot about 20 years ago and that I'd used to encrypt some useful documents. I don't know. Maybe we'll get there. Maybe we won't. Have you used AI to code? What have you built? What would you like to build? Let us know in the comments, and be sure to subscribe to this channel for more.